In this video, I'm going to talk about a tricky topic called graph shifting. We're just going to introduce it today with absolute value functions. Okay? And to get into graph shifting, what we want to start looking at here is the graph of what we call a parent function. And a parent function or a parent graph is just the function in its most basic form. So here we have y equals the absolute value of x. Now, if we're taking a look at y equals the absolute value of x, let's just take a few points and graph this to see what the picture of this graph will look like here. Okay, what I'm going to do is just take a few x values and plug them in using a chart to find out what the y values are. So if I plug in this first part, -2 goes in for x. The absolute value of any number makes it positive. If I plug -1 in for x, the absolute value of -1 is +1. If I plug in 0, the absolute value of 0 is 0. Plug in 1, we get 1, and the absolute value of 2 is 2. So if I keep checking these and I look, and I were to actually graph this now, we've got the ordered pair -2, +2, so that would go here. We'd have the ordered pair -1, 1. We have the ordered pair 0, 0, 1, 1, and 2, 2. And what you notice here is that an absolute value graph will always take on this little V shape. Okay, this is what we call the parent graph for absolute value function. So if I kind of move this here and extend my graph, and that would keep going in that kind of up one, over one sort of pattern in each direction, so that we have almost a V shape with the absolute value graph. Okay. When we get into the idea of graph shifting, you always want to go back to what the original graph looks like. And all the shifting that's going to do is just going to take this graph and move it around. For the purposes of today, or for this video, I'm not going to get into things that will make your absolute value skinnier, flip it upside down, or make it wider as well. Okay? I'm only going to look at taking something and moving it somewhere else in the graph. Okay, so let's take a look at the actual function here. So this is the general form of a function here for an absolute value. So this is the one you're going to look at that when you're trying to see where your graph is going to be shifted or how it's going to be changed. This is basically an like slope intercept form, but for an absolute value, where this helps you quickly graph these things when it's in this form. So if we have a times the absolute value of x minus h plus k, here's what you need to know to graph this. Okay? If we go back here, this point here at the middle, we're going to refer to this as your vertex of your absolute value. Okay? And this is an important point to graph. All right? It's sort of going to be like the y-intercept when you're graphing lines, in that it's a great starting point when you're graphing these. So if I go back here, the way we can find the vertex is by looking in here and looking here. Okay? To find the x-coordinate of your vertex, you're going to have to take the x minus h stuff in here. So for example, that might be like x minus 3, and set it equal to 0. And what you want to do is solve that. So if I were solving this, I'd add 3 to both sides, and that would tell me that the vertex would be at an x-coordinate of 3. Okay? To get the k, this is sort of like a y-intercept for the b. It just moves your graph up and down. Okay? So that would move the vertex, or the middle kind of point of the v, that would move the vertex up however many units. So if this was like a 2, that would move your graph up +2. So you'd have the ordered pair 3, 2 to make your v. And then if you remember the parent function, okay, all we did was we shifted that original graph that was right here. So we had that original graph that looked like this, and we would move it over 3 units and up 2 units, and then redraw the exact same graph up here. So our final answer graph would be right here. So what this x minus h and this plus k stuff does is this shifts the graph around. So we can keep the graph exactly the same. It makes it easier than graphing it using a chart. We don't have to keep plugging in numbers or guess where that vertex is. Like the vertex might be all the way out here somewhere, and we might be trying out all these points, not even getting anywhere near it. So if we're trying to get a complete picture, this is a much easier way to do that once you get good at this. Okay? Let's try an example here. We've got y is equal to x minus 3 plus 2. And this is actually the example that I just tried out. So I'm going to go through this a little slower now. The first step is define the vertex here. We know that the parent graph looks like this. It's going to be this V shape type thing. And we want to see where this gets shifted to if I have an x minus 3 and a plus 2. Again, set the x minus 3 part equal to 0. To solve, we've got to add 3 to both sides. So that tells me that the x-coordinate of my vertex is at 3. Okay. Now, to find the y-coordinate of the vertex, that's just the plus 2 here at the end, which again tells me that this graph is going to be shifted over 3 and up 2, and that the new vertex is going to be right here. And then all I'm doing is taking all these points and shifting them over 3 and up 2. This point, over 3 and up 2. Again, we'll go to this point, over 3 and up 2. Last point, over 3 and up 2. And you can see that all we did is we moved this V shape off to the side. Okay, try another one. Now we've got y equals the absolute value of x plus 3 minus 5. Again, I'm going to start by setting this inside part here to find out where this graph is going to shift. So I'll draw the original function again here. So we've got dots. The V shape of the parent graph, which is the absolute value. Okay. And this is going to start by shifting our graph. If we have x plus 3 equals 0, if we subtract 3 from both sides, that will tell us that our graph is going to shift 3 to the left. And since this is a minus 5, that tells me that the graph is going to be shifted down 5. So our vertex will be at negative 3, negative 5. Let's go ahead and graph that. So it'd be, at left 3 and down 5. 1, 2, 3, 4, 5. There's our dot. Okay, and if we've got our negative 3, negative 5, now all we have to do is recount each of these points. So you can take this left 3 and down 5. Okay, you can take this point left 3 and down 5. You can take this point left 3 and down 5. And again, this point left 3 and down 5. And you're starting to see now that it still maintains this V shape. Okay. Now, there will be problems later. I won't get to these in this video where you'll actually change the graph of the absolute value before you shift things around. But for now, this is just an introduction to graph shifting and how things move. Okay. Moving right along. Got 2 more examples here. We've got y equals the absolute value of x minus 1. And you might not see a plus k out here sometimes, but remember, that actually makes our life a little bit easier. That means that this isn't shifted up or down at all. But what we do need to look at here is the left or right shift. So to set this equal to 0 here, I'm going to add 1 to both sides. That tells me that the vertex here is at 1, 0, which would be taking this parent function. Okay, so we're taking this parent function here, and we're going to shift it 1 to the right, and not up or down at all. So now again, all that happens is each of these points right here gets shifted 1 to the right. And I want to be clear that this blue line is not actually, it's still part of the graph, it doesn't really matter, but this blue graph is not part of the answer. This is really just a tool to help us get the answer. So if you want to go back and erase this, depending on who your teacher is, they may want you to erase that. I'll try not to erase all my other lines here too. But if you go back and kind of clear that blue line out of there, you can see the final graph will look like that. Okay, we'll take one more here. This one will be the absolute value of x minus 9. And again, to find the vertex, we're going to set the inside part equal to 0. And actually, you know what? Hey, that's easy. It's not shifted left or right at all. It's only shifted up or down. And in this case, this minus 9 tells us that our graph is shifted down 9. So our vertex of this new point is going to be at negative 9 here, so that should be a negative sign. 1, 2, 3, 4, 5, 6, 7, 8. And we're going to be a little bit off the graph, but that's no worries. We can make that work. We know that's the new vertex. And again, let's graph the parent function here. So we're going to graph this, and you'll get really good at graphing the basic absolute value function because you're going to use it so many times. So here's the basic parent function. It's the one where everything kind of starts from. And then we're going to start by shifting this down 9, which is just below the graph here. And then from that point, we'll shift this one down 9. Oh, doesn't want to write. Let's try one more time here. We're going to shift this one down 9 and this one down 9. We're going to shift this one down 9. Oops, missed that by 1. Sometimes you got to be real careful you don't miss it. I make mistakes here too. This one down 9. And the next one down 9. And again, just to double check, 1, 2, 3, 4, 5, 6, 7, 8, and 9. That should give us that nice V-shaped graph down here. And there you go. So again, introduction to graphing absolute value graphs. Your basic function or formula for this would look like this. If you're wondering where that A is coming from, you could have a number in front of this that is going to make these lines either steeper or wider based on what the number is. We're not getting into that in this video, but I will talk about that in the next video and how that number in front of the absolute value, like if I had a 2 out here, how that would change the graph.